name is Suresh. I'm working as an assistant professor in the Department of Computer Science and Engineering in Marri Laxman Institute of Technology and Management, Dundigal, Hyderabad, Telangana. So today we are going to discuss about one of the application of the divide and conquer strategy, that is MedSort. So here coming to this MedSort follows the divide and conquer strategy and works in three main steps. Those steps are divide, conquer, and combine. So here, while you are solving the MedSort problem, here take a list and divide that list into sublist and divide this sublist recursively until each sublist contains a single element. After dividing this list into sublist, again you have to combine those sublists. While you are combining the sublists, you have to sort the elements. So this is the main approach of the merge sort. Now see, let us see one by one method in detail. So here in the merge sort we are having three main steps. Those steps are divide, conquer, and combine. So in the divide, what we have to do is the given array list of elements are divided into two equal halves. So here after this, this divide continues recursively until each subarray contains only one element. Here we have to consider that a single element is always in sorted order. Okay, this is the divide. Now coming to the conquer, so here recursively you have to divide your sublist into some subarrays or sublist. So recursively how to do this one, and we have to sort the elements. And finally, if you want to get your result, we have to combine the sorted sublist. Finally, we are going to get the result. That means sorted list we are going to get. Okay. Now, so now let us see the algorithm for the MedSort. So this is the algorithm for the MedSort. Here I am taking MedSort and I am taking an array and I am passing low and high. And if low is less than high, then what you have to do? If you have to divide your list into two parts according to the mid value. So what is this mid? So mid equal to low plus high by 2. By using this, we have to calculate the mid value. Mid is nothing but low is nothing but lower index of the array what we are taken, and high is nothing but higher index of the array what we are taken. So now here we are divide. So now we have to calculate the mid value. After calculating the mid value, now we have to divide our list into two halves, and recursively you have to apply the same procedure, divide those two halves into again subparts or sub list by using same method. That's why here I'm using the same method, that is mid sort of a comma low comma mid and mid sort of a comma mid plus 1 to high, like this. So these two are used to recursively dividing your list into sublist. Okay, until this process we have to continue until each list contains a single element. After this we have to go for the merging operation. That means you have to merge the list. While you are merging the list, that means here how you are divided the list, in that fashion only you have to merge the list. While you are merging the list, here you have to sort the elements. Okay, and merge like this until all elements are sorted. Okay, now let us see the algorithm for again the merge method. Okay, so now the algorithm for the merge is given like this. Okay, algorithm merge low mid high. Here I'm passing low mid high, and after this here I'm declaring some variables h and I and j. I'm declaring here h I'm assigning to the low value, and I am assigning to the low value, and j I'm assigning to mid plus 1 value. Okay, now while h is less than or equal to mid and j is less than or equal to high, that means here our list is divided into two halves. Okay, now here we are comparing, okay, first half with the second half. Okay, and first of elements with the second of elements. If you find from the any one of the list, if any element is lesser, then we are going to store that element in a temporary array. Here we are taking a temporary array, we are going to store that elements into the temporary array. That means here this is for this h is less than or equal to mid is for the one sub array, that is, let us say it is a left sub array, and j is less than or equal to high, this condition is for the right sub array. Here we are comparing the one by one elements of the each sub list or sub arrays. So if you find any element is the lesser one, then we are going to store that element into the temporary array. And finally, we are going to print the temporary array. Then in the temporary array contains our sorted list. Okay. Now here the condition. Now just see the condition while h is less than or equal to mid and j is less than or equal to high. Then what we have to do here, we have to see compare. So a of h is less than or equal to a of j or not, that we have to compare. If a of h is less than a of j, that means here the h index value is less than the j index value. That means the left sublist value is less than the right sublist value in the jth index. Then what you have to do, you have to store that value into the temporary variable, that is a temporary array, that is a b of I. And after that you have to increment the h value. Okay, that means for comparing the next value with the right sublist values. Okay, left sublist next value with the right sublist next value, you have to increment this. Otherwise, if this condition fails, the meaning of this one is a of okay. So a of h is greater than a of j. The meaning of this one is the right sublist array element is lesser than the left sublist value. Then what we have to do, we have to store that value into the temporary array, and after that we have to increment this j value. That means simply here we are comparing the left sub list with the right sub list. So one by one element with the indexes h and j. When you are find that there is a lesser element, then we are going to store that into the temporary value, and after that we are incrementing the I. This I is for indexes of the temporary array. So this is a main logic for the merge. Now after this, if any elements are found remains in the left sublist or right sublist, we are going to store them into the our temporary array. So these two methods are going to be used, and finally we are going to store the temporary array into the our taken array, that is a, and we have to if you print the array a, then you are going to get the sorted list. Okay, this is the algorithm for the merge sort. Now let us discuss the one example for the merge sort. The example is given like this. Here I'm taking a list. So the list is contains the elements like this. Okay, now we have to, first of all, in the merge sort we have to divide the list into two halves according to the mid value. That means first we have to calculate the mid value. Now I'm representing the indexes here 0 1 2 3 4 5 6. Okay, so they are the indexes I have represented. Now let us calculate the mid value. What is the mid value now? Mid equal to low plus high by 2. That means here what is the lower index 0 and what is the higher index 6 by 2, that equal to I'm getting the 3. That means up to 3 you have to take it. That means up to third index we have to take as one sublist, that is we are taking as the left sublist, and so remaining, that means 3 2, that means 3 plus mid plus 1 2, that is the 4 to 6 we have to take in the right sublist. Now here what is the mid value? Here the mid is 3. According to this we are divided the list into two halves. Okay, so this is the left sublist and this is a right sublist. Again we have to divide these sublist into a left sublist and right sublist recursively until each sublist contains the single element. Now let us divide this left sublist into again equal halves, that is a 0 1 2 3. These are the indexes. Now let us calculate the mid value. The mid value here is 0 plus 3 by 2, that equal to 1.5 you will get. Let us take the 1. So that means up to 1, 0 to 1, that means 38 27 is divided into 1 half, and 43 to 3 will divide it into, that means the index 2 to 3 will be divided into another half. Now coming to this on right side, the same procedure we have to apply. Calculate the mid value. Mid is nothing, what are the indexes? 4 5 6. Now 4 plus 6 by 2, that means low plus high by 2. What is the low here? 4 and high is 6, that is we will get 10 by 2. This is equal to 5. Up to 5, that means of the index 4 to 5 up to mid value you have to take in the left sublist, and mid plus 1 to remaining elements you have to take in the right sublist. Okay, like this that list is going to be divided. Okay, further if you divide, so like this, the here observe this, the list contains the single element. Okay, after dividing the list into sublist until each sublist contains the single element. Now we have to combine them. While combining, we have to apply our merge logic. If you apply that merge logic, what we discussed, then obviously the elements are going to be, you are going to get in sorted list. Okay, now just see, observe here. So here, in which fashion you are divided, in that fashion only you have to combine the elements. See here, I have divided that this list 38 and 27 like this only you have to combine. While you are combining, you have to sort the elements by using the merge method what we discussed. And after that, here coming to this one 43 and 3, here you have to sort the elements like this. Okay, 3 and 43. Now here coming to the right side, 9 and 82 will be, you will get like this, and 10 you will get like this. And after this, here these sublist you have to combine. While combining, you have to arrange the elements in sorted order. If you combine these two, you will get the sorted order like this: 3, 27, 38, 43. And if you combine these two right side, you will get the sorted list like this: 9, 10, 82. And if you want to get your final sorted list, you have to combine these two. While you are combining, you have to eliminate the you have to arrange the elements in order. That is the, here we are taking the ascending order. So here I'm taking 3, 9, 10, 27, 38, 43 and 83 like this you will get. Okay, so like this is the approach of the method. Take a list and divide that list into, recursively divide that list into sublist until each sublist contains a single element. After that, we have to combine these sublist. While you're combining, sort the elements in an order, either it is ascending order or descending order. In our context, we are taking the ascending order. So this is working nature of the merge sort algorithm. Next, let us discuss the time complexity of the merge sort algorithm. So if you want to find the time complexity of the merge sort algorithm, so here we have to define a recurrence relation for this one. So the recurrence relation is given by like this for the merge sort algorithm. So the recurrence relation is T of n equal to A. If n equal to 1, that means if the input size, the list contains only one element, then you will get the constant time, that is A I'm representing. If the list contains more than one element, so then the recurrence relation is given like this: 2 into T of n by 2 plus C into n, where here C is a constant. This is a recurrence relation. So now let us see what are the terms present in this recurrence relation, where T of n is nothing but time required to sort an input of size n. Okay, how much time it is taken to sort the elements, that is represented with the T of n. And here we are having the n is nothing but number of elements in the input array. Number of elements in the input array. Okay, so here in this context you have to take small n. So is the number of elements in the array. So A is nothing but, it is a constant I'm taken for the n equal to 1. And T of n by 2, this is for dividing your problem into sub problem. That means dividing your list into sub list, okay, of size n by 2. And this C into n is nothing but time taken to merge these two sorted arrays. So this is a terms present in the recurrence relation. So simply the recurrence relation for the merge sort is, so this is a recurrence relation: 2 into T of n by 2 plus n, otherwise Cn. This is a recurrence relation. Now let us calculate the time complexity by using this recurrence relation. So let us take the recurrence relation what we got. So that is what I am writing it: T of n equal to 2 into T of n by 2 plus n. Let us take this recurrence relation and we will solve this particular recurrence relation by using substitution method. So we are going to get the time complexity of this merge sort. Now here T of n equal to 2 into T of n by 2 plus n. Now I want to find the T of n by 2. If you want to use the T of n by 2, use the same recurrence relation. Okay. Now by using this recurrence relation, if you find the value of the T of n by 2, then you will get the value like this: 2 into T of n by 2 plus n by 2. If you simplify this one, you will get this one: 4 into T of n by 4 plus 2n. This is the value you will get. Now again, if you want to find the time complexity, you require the value of T of n by 4. So here you find the value of T of n by 4 by using the same recurrence relation. So if you find this one, you will get the value like this: 2 into T of n by 8 plus n by 4. Now substitute this one in the given our main recurrence relation. You will get 4 into 2 T of n by 8 plus n by 4 plus 2n. Now if you simplify this one, you will get like this: 8 into T of n by 8 plus 3n. So if you continue this process up to some k substitutions, you will get the recurrence relation like this. We can write the recurrence relation, this one: T of n equal to 2 power k t into n by 2 power k plus kn. Now here, okay, we are going to stop this recurrence relation. If you want to stop, you have to assign this n by 2 power k to 1. Now you will get 2 power k equal to n. Now the k value is log n. Okay. Now I'm going to obtain the k value. The k value is log n. After that, substitute this k value in the recurrence relation. You will get the recurrence relation like this: t of n equal to n into t of 1 plus n log n. You will get the recurrence relation like this. And after this, we know that t of one value is a. That means a constant time it will take. So now let us substitute this one: t of n equal to n into a plus n log n. Now let us simplify this one. So you will get like this. Let us take the n as common. So t of n equal to n into a plus n log n. Okay. Now here we will ignore the constant terms, and after that, okay, so here we will ignore the constant terms, and after that take the, okay, highest polynomials of the n, then you will get the n log n as the value. So therefore the time complexity of the Metsart algorithm is n log n is the time complexity of the Metsart algorithm. So if you take uh, best case, average case, and worst cases of the Metsart algorithm, you will get the same time complexity. That means here best case, average case, worst case, time complexities of the Metsart is, so order of n log n you will get. So this is the time complexity. Because here, whatever the list you are given to the Metsart, it will follows the same procedure. Divide the list into sublist, and again recursively divide the sublist into, okay, again sublist until each list contains single element, and it will merge the elements. While merging, it is going to sort the elements. Same procedure it will follow, whether you are giving the sorted order or sorted list or unsorted list, whatever it may be, it will follows the same procedure. That's why for the three cases, that is best case, average case, and worst case, time complexities are same. The time complexity is n log n is the time complexity of the Metsart algorithm. Thank you.